Okay, on this example, Casey's flying a kite that is moving horizontally 77 feet above his head. Okay. So the first thing you get realize that one of the tricks on this problem is we've got a little triangle going on here. Let me draw this. All right, got a little triangle here. This is 77 feet above his head, right? And notice that this kite, did you notice they said the kite is moving perfectly horizontal, moving horizontally. So the kite's not going up and down. It's only as he lets out string, it's going perfectly sideways back more and more and more. That's what you got to get straight. Find the rate at which what they say right here, moving horizontally, sideways, not up and down. Find the rate at which the string is being paid out when the kite is moving horizontally at a rate of 8 feet per second. So it's doing this at 8 feet per second. And the string is 85 feet long. So the string is 85 feet long. Okay. But having said that, let's go to step number one. We got to find the rate letters. So what are the rate letters? Well, they're asking us to see, oh, this right here. Okay, so how do you do that? Well, that's this distance, isn't it? That's how far the kite is horizontally from him, and that's dx dt, and that's increasing. It's 8 because it's increasing. We're assuming that kite is going away from him as he lets out string, of course, right? As he lets out more and more string, that kite is moving horizontally. They said so. It's not going up or down. So that x, that distance from Casey to the kite horizontally, is increasing by 8 feet every second. 8 feet every second. It's getting further and further away from him. 8 feet every second. So that's the first one they mentioned. And what else? What are the rate? Find the rate at which the string is being paid out. So we're going to need to call this like y. Here, let's put it in right there. Call this y. Now you might say, well, it's 85. Well, yeah, at this instant it is, but it's a variable. He's been letting more and more string out. And so that's what we want to find out. How fast is the string going out? That's what they're asking us to find. Find the rate at which the string is being paid out when the kite is 85 feet away. When the string is 85 feet long. All right, so there we go. There's our rate letters, which is always the beginning of any related rate problem. So number two, um, find some kind of equation relating only those letters, right? Only those letters, which is what? X and Y. Those are the only, you can have other numbers, but no other letters, just X and Y. So that means I don't want to bring in theta or anything like that. So X, 77Y, that's pretty easy, little right triangle there, right? So we're going to go, okay, it's easy. So X squared plus 77 squared is Y squared, right? That 77 is always a fixed 77 because why? Because the kite is moving horizontally. It's only moving sideways. It's not getting higher or lower. So that 77, the height the kite is above him will always be 77. So there we go. Step three. So there's an equation. It has only X and Y, no other letters, and then it has the number. And then you know the deal, d dt of both sides. All right. Come in here and go d dt. Derivative with respect to time. All right, and bring down the 2. Here we go. We're going to get 2x times dx dt plus 0, right? This is a 0. It's just a number. The numbers don't change, so the rate of change of that number is 0. And then 2y dy dt. And we can immediately say, hey, let's get rid of these 2's. Boom, boom. So now we've got x dx dt is y dy dt. That's nice. All right. And step 4, plugging in the numbers. All right. So we have the y is 85. You do that. Y is 85. Isn't dy dt what we're trying to find, I think? All right, dy dt is what we're trying to find. Right, dx dt is 8. Got that one. Dx dt right here is 8. So then what's x? Do we have x? Well, we can get x right here, right? We can say, well, x squared plus 77 squared is 85 squared. Now that we know y is 85. And so then bump this over here. So x squared is 85 squared minus 77 squared. And then root it, root it. So x is the square root of whatever that is. We'll let Desmos tell us. 85 squared minus 77 squared. There's x. So square root of, oops, I have my tool on. Square root of, there's x. Square root of 85 squared minus 77 squared. Yeah. So there we go. Now we can solve for dy dt. Get that alone. Divide on both sides by the 85 by. So dy dt then. We go to Desmos. So this is multiplied by 8 outside the square root there, right? So 8 square root of 85 squared minus 77 squared. Fraction square root of 85. Oh, square root 85 squared minus 77 squared. Then outside the root times 8, was it? It was 85, 77, 8. Yeah, 85, 77, 8 over 85. Over 85. Boom, there we go. 3.3882, 3.3882, 3.3882, 3.3882. So if they got it, 3.3882, there it is. That's feet per second. That's how fast the string is going out right at that moment. And so there we go.